Hello everyone, today we're going to be showing the electrolysis of sodium chloride, also known as table salt. So I'm going to explain what happens later, but this is just the current process. So I have two electrodes, one copper and the other copper, and then I have a 18-volt battery currently supplying 12.2 volts electricity at about 4 amps. Oh, wait, no. Believe I should be able to check. Giving off very little, but that doesn't really matter. So basically, the little orange flakes, I don't know if you can see, let me see if it'll focus on my finger. Anyway, there's little bits of orange, and that's just from the copper. It wasn't very cleaned well, but the white stuff I do not know, but like I said, I'm going to explain what everything is when I'm done. Alright, we're back. So, this was, I believe, our positive. So it has little, like, light green on it. Kind of like a teal type of. And then a negative is just kind of dirty. And then, so you have the super light where the positive was. And then just a little bit of lack of where the negative was. And then the rest is this just green, weird stuff on the top. So, don't know what it is. We're gonna find out. Alright, so I have a 1 liter Erlenmeyer flask with a coffee filter and then a funnel. So, let's pour. It's warm. Quite warm, actually. I don't think we actually need this funnel, so let's put this in the bath. There we go. Okay, my hands are all weird now. Alright. Should probably pour this into a beaker first. Let's do that. 250 should be fine. Alright. So while this is dripping away and collecting the thicker stuff on top, I poured the rest into this smaller Erlenmeyer flask, and I'm going to see what reacts with it. So first we're going to put in some washing soda. I don't have any baking soda, so that's close enough. Alright, let's put this camera down. Okay. I'm gonna get some. There's a scoop. Here it is. I'm gonna clean it off. Alright. Doesn't appear to be doing anything. Yeah, it doesn't appear to be doing anything. If we add a little bit more. Although, it looks like the flakes are separating a bit. that might be of importance. But I might not be able to find out at this second. Alright, that should be enough to react with everything. Yeah, it's weird. Look at this. It's like all clumpy. It's weird. Kind of reminds me of when I did my iron experiment for rust. I think it's turned a little bit more yellowish. Still warm. I don't understand how it's getting this warmth, but it's getting the warmth somehow. So, let's pour a little bit back into the beaker. Okay. Now let's see when we add a base, liquid base. Looks like I'm just diluting it, basically. That has flakes in it, and this does not. Looks like lemonade in real life. Alright? Sorry, I'm looking for a container. This should be good enough to put this access in, because I don't really know what it is. Alright, got a bucket. Bucket right here. There you go. I'm just gonna pour in this beaker into it. Looks like yummy lemonade, but it's not whatsoever. Alright. Now, so we put in washing soda, and nothing happened. So, what happens when we add alcohol? Now, sometimes when I use alcohol, it separates the molecules and other things. Sometimes it doesn't, and usually it doesn't do anything, but 91%. Can't touch the camera right now. So we have 91% alcohol, so let's add it in. That should be enough to warrant a reaction. That's getting really warm. It's weird. It may actually just be reacting with the air. Or at least the oxygen in there. Now this would make you think, oh, what about hydrogen peroxide? I don't have any of that on hand, but I do have water, so it's worth a try. Let's pour some more. Should be enough. Should probably stop wasting it completely. Alright. Making sure you see it. Just add. So, actually, I'll just pour the rest in here. It's gonna need some more water. I want to dilute it, so it's as clear as I can make it. Yeah, there you go. So we have a 250 milliliters of the water in that strange mixture. So I can see through. I don't think you can. So this mysterious mixture came from salt. Look how dirty my gloves are. Should get some better gloves. Anyway. When we take the salt, just put it in. Wondering if anything will fall out of solution. That should be enough. Wait, a little bit more. Alright, let's mix this together. No, there's a copper flake in here. A couple of them, actually. So I'm wondering if this might be an actual acid. Because it didn't... Wish I had another acid to test it with, but I don't. I'm very low on supplies right now, if you can't really tell. Let's put some more in. Doesn't look like anything's precipitating. I think this is an acid, actually, because it appears to be dissolving the copper very, very slowly. Extremely slowly. So, if it's slowly doing that... Anyway, let's add some non-diluted. Okay. So it's super, super diluted. I mean, not diluted. So let's just put it in here. See if any copper flakes start to come off. It's getting very warm. It does appearing to dissolve the copper at a little bit accelerated rate. You know what? I think when it's moved a lot, it may actually, that's what it's reacting with, the oxygen to warm up. But I'm not sure. No? Huh, that's weird. But yeah, it does appear to be dissolving the copper a little bit, yeah. So I think it's an acid. Well, it should be anyway. So I'll do some more research, and I'll talk to you at the computer. Wait a minute. How am I going to end this? I need something to poke it with. Ah! No, that won't work. This is good enough. Alright. So, this is what we did when we did electrolysis. So, basically, the reaction was 2NaCl plus 2H2O is equal to, and then the chlorine gas and hydrogen gas. Chlorine comes from the negative. Hydrogen comes from the positive, I believe. I'm not sure about this. And then plus 2NaOH. Na2OH is sodium hydroxide, also known as lye. And then here is, whoa, the chemical safety. So 301, and then alkaline, I believe. Alright, thank you for watching. Bye bye.